Thank you, thank you. You said 28 years as if that was a surprise. I was 3 when I started. So so there's what, okay, so that's what the surprise was. It wasn't that you how could, that's such a long time. Wow, way to really set me up. Excellent, fantastic.
It's an impressive thing.
You're walking
I
that
was
back
not trying to age
relatively
you.
well. Yeah,
Yes.
keep trying to dig yourself out. That's good. I appreciate the effort.
Please continue sponsoring our party.
That's right. Well, I mean, I haven't swiped the card quite yet, so yeah, we'll see how that goes. Give it up to organizers, James and Ahmed, for putting this on. Also to all the other sponsors that are here. Without them, this definitely would not happen. So definitely, go check out their websites, talk to the representatives here, and thanks to all the other speakers for taking the time out to get here. Whether it was even if Work's funding it to get here, it's a lot of effort and a lot of time. And even more so if Work is not, and you have to kind of take your time out. So definitely, let's give it up again for the speakers that are here. All right, let's see. Did I waste enough time that I don't have to talk? No, we're going to have to go. Okay, so we're going to talk about high-performing engineering teams and the Holy Grail. And yes, there will be a few of these GIFs throughout. And let's kind of jump into it. So, software delivery has never been more, critical to the success of a business, large or small, in pretty much every industry. And it's also, never been more complex. If you think back to, years ago, the things that were classified as, wow, that's just an amazing experience on, whether it's the web or application development. Now that is pretty much considered to be that's the bare minimum. But it also has to be done, faster than it ever was before. So all of those experiences make it a whole lot more difficult for engineering teams. And then the landscape of tools and platforms and the architectures, it's constantly evolving. This is the CNCF Cloud Native Computing Foundation's landscape that they put together. I could not make it any bigger. So you'll have to, either go check out my slides later and zoom in to even get some of these names. You might recognize some of the logos, but this itself was taken. I think I got this earlier this year, and it's already changed. So I probably should update my slide. But the point here is it's always evolving. And so how can engineering teams not only succeed but beat out the competition when the choice of things here just continues to become more of an issue? So hi, my name is Jeremy Meiss. As was mentioned, Director DevRel over at CircleCI. Really glad to be here. You can find me on Twitter there and a couple other links later. Let's go. So back to the tech industry. We've really entered into this period. And it's not really entered. I mean, we're smack dab in this period of immense change. And so with the global economic uncertainties that are kind of presented, it's really impacting companies of all sizes, from startups all the way up even to enterprises. And even in this environment, the stability and reliability of those systems has become increasingly important to businesses globally. The ability for teams to provide a reliable, stable platform to customers has become really that crucial value metric that engineering teams can offer to a company, and is only going to continue to increase in importance in years to come. And when we think about what it takes and the importance of prioritizing things like continuous integration. Forrester did a study just 2 years ago talking about best-in-class CI/CD platforms. The value that they provide could not be even more. That's millions of dollars over time, and it's not even over 20 years. It's over a very short 3 years or less. You can see these values of implementing best-in-class CI/CD. But as CI adoption has really expanded over the last several years, we've seen a lot of teams have had kind of this grow at all cost mentality. We have to get as fast and as big as possible and work on the most important things. But even with that complexity of all those software systems has increased as well. And so the cognitive load for maintaining those systems has really become, I'd say, probably pretty overwhelming for both the devs and ops sides of the engineering departments, which creates situations where teams start to cut corners. We've seen DevOps teams taking away some of the complexity and being in a position to kind of try and help those systems recover quickly from failures. And so we've seen the companies, as a result of that, start to implement platform teams. And Leslie's talk earlier was fantastic around what platform teams are and the value that they add and how you can integrate them in. Yeah, could not say, it was great. Love the talk. So you've seen these platform teams start to develop. And so the need for that dedicated team that's going to support the stability of their application has really become obvious, and we're going to kind of come back to that later. Now, there was some talk about DORA report earlier. Definitely a great report on survey data around engineering teams. Since 2019, we've been putting together at CircleCI kind of analyzing anonymous data from users of our platform to identify like the set of recommended baseline engineering metrics that relate to CI/CD. So kind of taking it that one step further, and not just from survey data of engineers trying to remember what they did yesterday and how, and hope that it was that they remembered correctly, but also taking and kind of matching that up with actual data to see how things kind of, what kind of rises to the top. What are those high-performing engineering teams, and what are the software delivery practices? But at the same time, we really don't believe that there's any such thing as like a one-size-fits-all metric. Because every team's different, every company's different. Unless you are Netflix, you're not Netflix, you're not Google, you're not these teams that get talked about as being high-performing engineering teams. You are just your company. And so it's important to kind of understand what are the, look at those data points, look at the software delivery patterns that we've kind of observed, and kind of identify what are those baselines, getting those key similarities across the different platforms and across the different, those metrics, and be able to kind of see what kind of comes for teams that they can start to use as those benchmarks. So what these tend to be, and now there's a nice line through there, but the benchmarks that we've identified for high-performing teams come down to duration, mean time to resolve, success rate, and throughput. So those are your four, when you think about a high-performing team, checking the boxes there, and we're going to go through kind of each one of these of what they are. And hopefully, you probably came to this talk thinking, hey, you saw it on the list, how am I going to achieve elite status through holistic software developer delivery practice? Hopefully I'm putting words in your mouth, or you just thought I wanted to hopefully see some Holy Grail gifts. Yes, we're going to kind of get there, hopefully not have concussion afterwards, but I make no promises. Either way, we're going to have food and drink later, so hopefully that'll help. So looking at the data. So the first metric, duration. That really is kind of this, it's the foundation of software engineering velocity. It's going to measure that average time, in the minutes that requires to move a unit of work through your pipeline. So, that unit of work really, it does not always mean like deploying to production. It really could be as simple as, running a few unit tests on code, on a development branch. It also it can really probably be best viewed as a proxy for how efficiently your pipeline delivers feedback on the health and quality of your code. It's probably a good way of thinking about duration. Now, the core premise of most software delivery paradigms, from agile to DevOps, is speed. It's the ability to take in information from your customers or your stakeholders and respond quickly and effectively. So, that rapid feedback that is important there in those delivery cycles, they don't just benefit an organization's end users, they're also critical to keeping your developers happy, engaged, and in kind of an uninterrupted state of flow. So when we think about that, an exclusive focus on speed often does come at the expense of stability. If you're always trying to get things fast, you're not going to be as concerned with, maybe you're not going to put testing in there, which you should be putting testing in your code. We don't like doing it, but we really should. But a pipeline that's optimized to deliver, those unverified changes by not putting in testing is really nothing more than a highly efficient way of delivering buggy code. If that's what you want to do, great, do it. Your customers are probably not going to like it, which means they're probably not going to buy your product, which means you're probably not going to, find a space at your desk to do your work. So, to be able to move quickly with confidence, you need your pipeline to guard against, all the potential points of failure, and to deliver that actionable information to you, allowing you to remediate those flaws, immediately before they reach production. And that's kind of the goal of what continuous integration is. So when we think about the duration benchmark, we've seen it's at less than or equal to about 10 minutes builds. Paul Duvall in his work in 2007 called Continuous Integration, he talked about, it is that good rule of thumb, keeping your builds to no more than 10 minutes. Many developers who use CI follow that practice, not moving on to the next task until their most recent check-in integrates. So you run the risk of, anything longer than that 10-minute time, you're interrupting flow, and you start to run the risk of, developers moving on and doing other things and never coming back, or taking longer to get back to something that breaks, which then is going to impact your mean time to resolve and all the other things we'll talk about. So when we think about the data, what we saw on our platform, and when we think about the data, we're talking about millions and millions of workflows that were observed, not like 1,000 this one day. We're talking about millions and millions of workflows. So the workflows that were observed, 50% of them completed in that 3.3 minutes or less. We had 75% were kind of completing in the less than 9 minutes. And then the fastest were at the 25% completed in under a minute. So when you think about the average, that was approximately 11 minutes, which reflects the influence of what, those longer running workflows that were there, that was in the, it's not listed there, but in the 95th percentile. Some of those were requiring 27 minutes or more to complete. And one quick note on that when we think about durations, your code, you might be running something that is going to take a long time. And so you may not be able to get down to a benchmark of 10 minutes or less. If you're building C modules, that's probably not going to get there. The point there is understanding what your data is, identify the benchmarks, and put in place principles to get you closer to more efficiently running code. So we may want the benchmark to be 10 or less, but you may not be able to get there, but you can get down the path. All right, so many teams continue to kind of bias towards speed, like I said. So, showing here, number one opportunity we've identified for, improving performance across all of the 4 software delivery metrics is for, organizations to enhance test coverage. Get more, have more robust test coverage, getting those unit testing, getting more code coverage, static, dynamic security scans, incorporating test-driven development practices. All of that's going to help you in improving the test coverage, and then optimizing that. Balancing the workflow speed and test coverage is ultimately a matter of prioritization. Which features are really a part of that critical path in order to get to that. Where can you afford for more experimentation and risk? Maybe you do that on different branches than you would do on a production branch. Like, all of those different things is important for understanding where you can optimize. But once you have kind of that buy-in from important stakeholders on how to balance that test coverage and workflow speed, you can optimize your workflow duration with these techniques here. I'd say one of the biggest ones, caching your dependency and data, so you're not rebuilding unchanged code, is important. That can really kind of help when you think about NPM modules, those thousands of modules that are in there that you probably don't need. You don't have to rebuild them every time if they haven't changed. So little things like that is going to help optimize. The path to optimizing your workflow is not always a dance routine. It is important to combine comprehensive test practices with your efficient workflow orchestration. Teams that are focusing solely on that speed, they not only spend more time rolling back the things that they've pushed, the broken updates and debugging, but they're also facing that greater risk that was talked about in organizational reputation and stability. So mean time to recovery, that's the next kind of metric here. It really is indicative of your team's resilience and ability to recover and respond quickly and effectively to the feedback that they get from the CI system before things get to production. So in other words, mean time is really the best indicator of how mature your organization's DevOps practices are. Now, from an end user perspective, and for a lot of organizations, nothing is really more important than your team's ability to recover from that broken build. So while customers may not notice the steady stream of the granular updates that you're pushing throughout the week, for instance, they're definitely going to notice when you ship broken code. So don't ship broken code. It generally is kind of how we view that thing. A key part of doing continuous build is that the mainline build fails. It needs to be fixed right away. So the whole point of working with CI is that you're always depending on a known stable base. It comes from Martin Fowler, who was one of the guiding principles around DevOps and what continuous integration even is today. So when we think about the benchmark, 60 minutes or less on default branches, not on your testing branches, not on your development branches, but your default branches, your mean time to resolve should be 60 minutes or less. It's going to, depending on the scale of your user base as well, your target recovery time may be significantly lower or it may be significantly higher. But your ability to recover in under an hour is strongly correlated with other indicators in the industry of what a high-performing team is, and it's going to allow your organization to avoid the worst outcomes of prolonged failures. Anytime after that, about an hour, is when warning signs start to pop up in social and in your businesses, your customers start calling your support teams, and all those things start flagging. So 60 minutes or less is really where you need to be. So on our platform, what we saw was 50% of workflows recovered in 64 minutes or less, which was pretty near to that 60 minutes. We did see a significant improvement over the previous years, which showed median times were about 10 minutes longer. Which was about the most notable change among any of the four metrics that we saw. The top 25% recovered in 15 minutes or less. The top 5% was recovering in under 5 minutes. Generally, that is an indication of what my code base generally looks like is crap. I just pushed the wrong thing. Let me push the right thing. So that's usually that like under 5 minutes or less. Testing your, the first step that you're going to take to lower your recovery times is treating your default branch as the lifeblood of your project. So by extension, your organization. While red builds are inevitable and you kind of want them, that way you're not pushing bad code. Getting your code back to green should be everyone's top priority. So everyone should stop, push. Let's get this fixed so we can move on. Having that kind of culture in place, your organization is going to be poised to kind of really leverage a lot of the data that they're getting from the CI system and remediate those failures as soon as they come up. Steps to kind of get to those faster recovery times. I already mentioned the treating default branch. Recovery speed is going to be inextricably bound to your duration. So if your pipeline is taking 65 minutes to build, you're not going to get back to a green build in less than 65 minutes. So it's very much tied to that. The shortest possible time is just going to be the length of the next pipeline build. So these techniques here kind of really help. They require that the previous mentioned optimizations around duration are in place, and then you can start to kind of get into faster recovery times. One of the big keys here, in clear, informative error messages for tests is also important. Will help you get to that, fixing that build a whole lot quicker than having no testing or no error messages or go check this system. Like that doesn't really help you much unless you know what you're looking for, what the actual error is. So it's important there. Being able to SSH into a failed build machine also lets you help in that debug in that remote testing environment. All right, third one, success rate. It is another indicator alongside of MTTR of the stability of your application. And of your whole kind of application development process. The impact of your success rate on both the customers and development teams is going to vary according to a number of factors like did it occur on the default branch, which means they're probably going to feel it in production, or was it a development branch where nobody really cares? Did the workflow involve a deployment? How important is the application to the service that's being tested? So those things impact success rate. A failed signal is not necessarily indicative, though, of something that has gone wrong or that there's a problem that needs to be addressed on a deeper level than a standard recovery process. It's far more important that your team's ability to kind of take that signal quickly, so that comes for that duration, and remediate the error effectively is going to be that MTTR. So a failed workload that delivers a fast, reliable signal is far more desirable than a passing workflow that offers like thin or unreliable information, even as of what it is. So we think about a benchmark for success rate, 90% or more on default branches. The key there is the default branch. It is a reasonable target for development teams that are working on mainline code of a mission-critical app, where those changes should only be merged after a series of tests, well-written tests have been performed. There's kind of a theme here. I think somebody had hopefully sees that. Failures on topic branches are generally less disruptive to your workflow because it's just test. It's just a development environment. You're trying new things. You want success rate there to be low because that's showing you that you're testing things, making sure things are working. Trying new things. That's more indicative of having lower success rates there. So it's important for your team to kind of set its own benchmark for success on those other branches, though. That way you make sure that you're at least not failing 100% of the time, that you have some level of success on those, but it should not be in that 90% or more. So among users, success rate on the default branch was about 77% on average. On the non-default, we saw about 67%. So on that default, it's kind of held steady on those default branches. And while neither number is really at that 90% benchmark itself, the pattern of non-default branches having higher numbers of failure does indicate we're starting to see a lot more teams that are effectively utilizing good kind of branching patterns so that they are doing a lot better testing, a lot better do development, trying new features. We definitely saw that as well through COVID, through 2020, 2021, and those two reports actually have some really great data. I'll have some links that you can check those out later. Now throughput. This traditionally reflects, the number of changes that your developers are, committing to your code base in a 24-hour period. I've seen data that like Amazon commits, hundreds of times an hour or it's 100 times a minute across all of their code bases. That's, ridiculous. But at the same time, large organization, large number of developers, like that fits. Again, it goes back to you're not Amazon, you're not Netflix, you're not these big organizations that are able to do huge amounts of throughput. So it is useful as a measurement of team flow, as it is tracking how many units of work are moving through the CI system. When you're performing at or above, recommended levels, it does put that continuous in continuous delivery. The higher your throughput, more frequently you are performing, work on your application. But of course, throughput also tells you nothing about the quality of work that's actually being performed. So it's important to kind of consider the richness of like that test data you have, as well as your performance on other metrics like success rate and duration to get that complete picture. So as with duration, a high throughput score really means little if you're frequently pushing poor quality code to users. So when we think about like what an ideal throughput would be, it depends. It is a standard DevOps answer, and it does. It really does depend because every organization is going to be different. They have different goals. A large cloud-native organization that's actively developing a critical product line, it's going to require far higher levels of throughput than a small team that's maintaining legacy software or niche internal tooling. So it really does depend on what you're doing. There is not really a universally applicable throughput target. It needs to be set according to those internal business requirements. The type of work, resources, all that stuff. So in our data set, the median workflow was at 1.5 times per day, which was a slight increase from, it was 1.43 in 2022. Upper end of the spectrum, it was the top 5% of workflows ran 7 times a day, which was on par of what we've seen kind of previous years. Average project had 2.93, in 2023, which is a little bit better than 2022. It's not really especially notable in terms of something that maybe happened, but when you take in kind of combination with the sharp decrease in mean time to resolve, it's probably what we've kind of been able to see is it's reflecting teams are committing to smaller, more frequent changes to limit that complexity of outages than large builds that potentially can cause bigger outages. So the four of the metrics, throughput is really the most dependent on the other metrics. You can't do 15 builds a day. Sorry, you can't push 15 builds a day when your pipelines are taking 2 hours to run. 15 times 2 is more hours in the day. So it's important to understand that throughput. That's why we say throughput is not like a big standard, because it is so dependent on the other metrics. So to improve the throughput, you first got to address the other three. It is also, though, a trailing indicator of the other changes in your processes and involvement in environment. So rather than setting like an arbitrary throughput goal, set a goal that reflects your business needs. Capture that baseline first, understand what you're doing now, and this applies for all the others. Understand what you're doing now, and then identify where you need to be and where track those changes and report on that, as opposed to some arbitrary, well, we want to get to 5 a day, and not understanding that that's just not possible. So measuring and then optimizing, these three are these four on duration, mean time to resolve, success rate, throughput, really gives teams tremendous advantage over organizations that aren't tracking these. So when we think about platform teams, which a number of people have talked about over the last 2 days, which it's great to see, we think about this idea that platform teams, DevOps, like they're maybe separate, maybe different. Some have even said there's a big thing going around over the last year, like DevOps is dead. Well, it's not. DevOps is not dead. DevOps and platform engineering, they're two sides of a same coin. They're depending on what your team is doing. You're going to have both of those in place. DevOps itself is a principle. It's a mindset of putting culture ahead of tools, breaking down the silos, growing lines of communication between your dev and ops teams. That in itself has been a good thing in the industry, but it's not going anywhere. And it does still form the construct of what a high-performing organization, engineering teams, how they function. So at the same time, though, when we think about the complexity of modern app development, there is a need for devs to learn new tools. Sometimes, infrastructure, while they're coding and prioritizing, ops tasks alongside of that feature development. So the weight of those demands, it does kind of lead to lower levels of productivity and effectiveness. So we've seen that show up in stress, burnout, reduced job satisfaction. So as a result, with that cognitive load increase, a lot of companies have seen driving up those errors and negatively impacting customer experience as well. So some of the practices that we've seen with platform teams is being put in place where it's that logical extension of what a mature DevOps organization looks like. However, it's designed to work alongside existing concepts while alleviating that associated cognitive load. Bringing self-service, you've probably heard kind of that self-service idea for your dev teams. It's kind of bringing that self-service idea to DevOps. Platform engineers, their really kind of idea is to abstract the complexity of a lot of the DevOps processes in place into kind of an internal development platform. Some call it an IDP that your internal teams use in order to spin up the resources and tools that you need, your engineering teams need to be successful. So when we think about CI/CD, there's a number of ways that platform engineers can really kind of help contribute to these metrics for high-performing engineering teams. With duration, really developers naturally gravitate towards speed, and so while platform teams, they tend to be tasked with identifying and eliminating the impediments to developer velocity. It's not really their only mandate. They also have got to make sure that the guardrails and quality standards are in place across the project. So those optimizations are going to save valuable developer minutes without sacrificing quality of your build. So that's one way that platform teams help with duration. We think about mean time to resolve. They form that bridge between organizations' business goals and its software delivery practices. So, having developers being equipped to recover from broken builds quickly is going to have a significant impact on that organization's bottom line. So, platform engineers really can kind of improve mean time to recovery in a number of these ways. Somebody talked about, I forget what it was, about infrastructure as code. That is a very important piece as well, because you can limit the need to remember all of the different steps that you might have in place. Success rate, it can be tempting as an organization to kind of chase a success rate of 100%, or interpreting high success rates as that indicator of, hey, we're elite software development teams, we should, we're great. It is desirable to maintain high levels, we've already talked about that, but it means very little if you're not confident in the signal you're receiving from CI. So platform engineers, they really have that responsibility to look beyond surface level metrics and really dive into what's actually happening and seeing some of the patterns and influence that maybe external factors have. And then throughput, kind of the last one. It exists primarily to remove blockers. The platform engineering teams do to remove those blockers from dev teams, and providing all tools, resources necessary for an organization to achieve really that maximum productivity. So while throughput is often one of the top indicators we talked about of, to evaluate the performance of not just development teams, but also the platform team as well. If they're able to achieve the throughput necessary to help support those teams, you're going to see it across the organization. All right, so this is the link to the report that has a whole lot more data, a whole lot more information, a lot more actual analysis of the data that I highly recommend you check out. You can get there. You don't have to sign up for anything to download the report. There are links to the previous year's report, so I definitely recommend checking those out, but you don't have to sign up for anything for that. And then here, love to hear feedback. If you want to get some swag, I have swag to give away, send it right to you. Just love to hear any feedback you have. You can find me on these social things, and that's it. Thank you. Any questions?